Hello everyone, welcome to Data Appreciation with Shino, and I would like to go over a Coursera creating basic visualizations using calculations. So it's an 8-minute video, um, but I found out that while taking it, there may be one or two gray areas for those who would want to try it out on their own. So I'm going over the video on creating basic visualizations using calculations. So calculations are calculated fields in Tableau. So the data set is the World Indicators data, and you have your here I have connected the data, so you can see we have 32 fields and 2,691 rows. So what I'm doing here is I will taking us through a few calculations in relation to this data. So what we did was we created, so where you have this alongside an equal to sign, it's a calculated field. So we have six calculated fields that we created, which is global average infant mortality rate, life expectancy weighted, education weighted, we have income weighted, and we have composite development index. So I can we can either look at the calculated fields through the data source window, or we go into our sheets to have a look at them. So we don't have a bit of distraction. Let's go into a fresh sheet, and on the canvas I will now show you our calculated field. So let's start from the top. We have the let's look at this. So we have the above global average for infant mortality. So I created the two because when you have the global average, you can have a infant mortality for the country, then we'll now have the greater than sign above the average infant mortality. So what was given it was the below global average. So you can see infant mortality rate, then we have the less than sign for average mortality rate. So next we're looking at is the education weighted. So the education weighted is average internet usage multiplied by 0.333. So 0.333 was picked as the, let me get 1 second, was the 1 second, so we can see why 0.333 was picked. So
Simplicity, in this demo, we assign equal weights of 33.3% to each indicator,
okay,
acknowledging that in real-world applications, these
so it was 0.33 was picked for the weighting. So that's what they actually use there. So that's what we're having the education weighted as the average internet usage multiplied by 0.333. So next we have the global average infant mortality, that is average against infant mortality. So next we have the income weighted. So it is the sum of GDP divided by the sum of population total, all multiplied by 0.333. That's our global weight. Next, we have the life expectancy. So for the life expectancy, we have the average life expectancy female plus the average life expectancy male, all divided by 2. and the entirety of it multiplied by 0.333. So I will go through the visualizations. So what we did here was have the country on our rows, which is our we have the our columns as the population. But now we now have a quick table calculation where we choose percentage of total. So each country has, so we can come here and put our population urban, so we can see the label. So we can see Afghanistan is 0.2, sorry, 1 second. So we can see the percentage of total as 0.2025 as the percentage of total for Afghanistan. So it's in 4 decimal places. So we can see it for each country. Then for infant mortality global average, what we did here was we created, remember we created the calculated field for infant mortality below global average. So we now use this on our color marks card, and for those that are above the infant mortality rate for global are put as false, and those that are truly below the global rate as true. So this is why we have it as red and green, and null values as blue. So remember also that they are on continuous, and for, so let us see if we can sort. So we can see for those above the global average, Sierra Leone is at the top, and at the bottom we have Singapore. So next we have the composite development index. So this is a tricky one. For the composite development index, which I'm going to show now. So for those who are taking this course, so for the composite development index, what we have on the instructions is education weighted, income weighted, and literacy weighted. So while doing it, I had a bit of a challenge. So I had to go back and check. So when I checked, I now found out that, let's look at somewhere I made a change. Yes. So what actually happened was that I had to, so on the training, on the lessons, if you go to where we have life expectancy weighted, you can see, so
female plus life expectancy male.
So
divided by 2 multiplied by 0.33.
that's what I had as a guide, but on on putting together, I found out that we had not put on the average, and I was getting an error for my own composite development index. So I had to bring in averages, and then that solved the problem, and I could get my visualization out. So, so when you do, you just remember that you would have to have. So let us have a look at it. Let us have a look at it. Not this. Life expectancy. So if we do what we have here, life expectancy, let's let's keep this aside. So if we keep this aside, we wouldn't get any error messages. So, but when we want to have our, let's take out this bracket, this bracket. So the calculation will be valid. So we can now see our composite development giving us error. So it's telling us we cannot mix aggregate and non-aggregate arguments in the function. So because our life expectancy weighted was not aggregated, so that's why I had the error message. So now if we aggregate it and we apply it, everything is balanced. So I just wanted to just so that that's where we had the issue. So if you're doing it, you may get the same error, and you see this as a solution to the creating basic visualization if you are trying it out on your own. So they don't have the error, but I'm just trying to say that this must have been something skipped while the video being created. So thank you very much, and see you in the next video.